All right, guys, here we go. Let's get right into it. Contextual questions. We're going to continue it. This is part 2. I recommend, if you haven't seen my last video called Cool Math Questions or Cool Calc Questions, look at that first, guys, because a lot of those questions, especially the very first one, the very first question really just is all about this here. So I recommend you watch that one first, and you might have a better idea. It is all a review, so it's not a lesson. So if you're weak on some of these guys, we might have issues. So let's go right into it. Hopefully at the end of this, you'll enjoy it and you give it a thumbs up, I hope. And if not, I guess you can give it a thumbs down. But I hope you enjoy this video. And let's get right into it, guys. So a particle moves along the x-axis such that at any time t greater than or equal to 0, its position is x of t, its velocity is v of t, and its acceleration is a of t. What is the average acceleration of the particle on the interval 0 to 8? Okay, so this right here, 1a 0 to 8 of v of t, this is going to give you average velocity. So there's multiple choice. We have to choose one, guys. If you remember from the past, we said average of f is equal to 1 over b minus a integral a to b of f of t dt, or f of x dx. And then why is this average velocity? Well, think about it. This right here gives you the displacement. And then you're going to divide that by 8. See? So displacement divided by 8, that is your average velocity, guys. That's your average rate of change there of your position, or your rate of change of position. So a of 8 minus a of 0, so divided by 8, this is going to give you the average jerk. This is just going to give you the change in velocity. From t equals 0 to t equals 8. And this one's going to give you average acceleration. Average acceleration. And I know what you're saying. I can already see Chavez, he just said that this gives you average acceleration. Well, it does, guys. These are the same thing. These are the same. So think about it. So if I write 1 over 8, that's an 8, but it came out funny. 1 over 8, 0 to 8 of a of t dt. Well, let's see, 1 over 8, and this right here is just going to give you your antiderivative acceleration is just v of 8 minus v of 0. V of 8 minus v of 0. So you can already see there, when I multiply those two, v of 8 minus v of 0 divided by 8 minus 0. So there it is, guys. And yes, I recognize that that's your average rate of change. So that is your average acceleration because you have change of velocity divided by time, which by definition is average acceleration. So hopefully that made sense to you guys. I think it's beautiful. Let's keep going. A particle travels along the x-axis such that its velocity is given by, and here's my velocity equation. What is the average acceleration of the particle on the interval 0 to 4? Okay, perfect. The exact same thing. We're doing the exact same thing, guys. Nothing changes. So I'm going to write v of 4 minus v of 0 divided by 4 minus 0. So change of velocity divided by time is your average acceleration. I'm going to put this in my calculator, so I'm going to zoom out so I can see, and then I'm going to type my calculator in here. So there it is. I'm going to go to y equals, and I'm just going to type x to the power 0.1. Yeah, that came out 0.1. And if you want to put 0.1, that's fine. Cosine of 2x plus 1. Close it. I'm going to go to my home screen, so second quit. And I'm going to do v of 4 minus v of 0 first. So I'm going to go alpha trace, enter, put a 4 in parentheses, minus alpha trace, enter, put a 0 in parentheses, enter. So there's my difference in velocity. And once I divide it by 4, you get your average acceleration. So negative 0.261. If you round it, it's 262. Negative 0.261. I did it truncated, guys. I don't have any units, so I'm going to leave it alone. All right, let's go to the next one. A particle travels along the x-axis such that its velocity is given by, again, so they give me velocity. Find all times when the speed of the particle is equal to 1 on the interval 0 to 4. All right, speed is absolute value of velocity. So what I'm going to do, and I want to find when my speed is equal to 1. So I want to find when the speed is equal to 1 on this interval. So I'm going to type this into y1. So again, I'm going to zoom out, and I'm going to show you what I'm going to do. I'm going to type the absolute value of that, guys. So there's two ways to do it. If you're paranoid, you can just type in x up to the power 0.5, close, and then sine of 2x. And then that's it. But that's my velocity. I don't want velocity. I want speed, correct? So I'm going to go to y2. And I'm going to push math. I'm going to go to number. And I'm going to push ABS, enter. And then inside that, I'm going to put y1. So there it is, my absolute value of y1. Y1 is my velocity. I'm going to turn off y1. So there it is. I turned off y1. I go to y3. Yes, I recognize, guys, you could have done one step. You could have done it in y1, absolute value of x to the 0.5, cosine of 2, sine of 2t, and that would have been fine. All right, for y3, I'm going to put 1. And there it is. So before I click on graph, guys, I'm going to click on window. I'm only looking between 0 and 4, see? So if you're only looking between 0 and 4, I'm going to put 0 here. I'm going to put 4 right there. And so you just care about the y value being a 1. So I don't have to go all the way to 10, guys. I'm just going to go to 2 here. And that's it. And then I'm just going to push graph. It looks like there are 3 values. And the way to find those values, guys, is to do the intersection here. So I'm going to go second calculate number 5, intersect, enter, enter, enter. That's going to give me my first one there. So there it is, 1.967. It's 8 if it's rounded, but 1.967. So t equals 1.967, comma. And then I'm going to find the other one by doing the same thing. Second calculate number 5. Enter, enter, and then when it says guess, you're going to scroll to the one that you want. So there it is. I push enter, and then I get 2.822 or 823 if you round it, but I'm going to say 822. 2.822, 2.822, comma, and then one more. Alpha, calculate, oops, sorry, second, nope, no second, trace. Second, calculate. Come on, buddy. Number 5. Enter, enter, and then scroll to the one you want. Enter again. Make sure it doesn't say the word guess anymore. 3.4269 or 427. 3.426. 3.426. Up here, guys, I would probably write one real quick statement. I would probably write something like absolute value t to the 0.5 sine of 2t close equals 1, and make sure that looks like absolute value or nothing else. So there it is, absolute value, and there it is. That's what I found, and these are my 3 values where that occurs, and that's it. You're done, guys. Cool, right? Cool. All right, let's go to the next one. So this one says, a particle travels along the x-axis such that its velocity is given by v of t equals 2 to the 1.2. What is the average velocity of the particle on the interval 0 to 5? Okay, this is just straightforward. We're just going to type it into our calculator. So first, let me show you the setup, guys. So the setup. I want the average velocity from 0 to 5. So I'm going to write 1 over 5 minus 0. If you don't want to put the 0, that's fine. Integral from 0 to 5 of this expression. T of 1.2 sine of 3t plus 4 close dt. If you want to write v of t, that is perfectly okay since they gave you v of t inside the stem of the problem. All right, so I'm going to zoom out so I can type my equation here. So here we go, y equals, I guess I'm going to delete all that. So memory 712. So here we go, y equals. All right, I'm going to write x to the power 1.2. And then come down, I'm write sine, and then 3x plus 4. So there it is. I have my velocity in y1. So now I'm going to go to my home screen, and I'm going to type that integral. So I'm going to go math, and I believe it was number 9, but I'm not sure. So let me scroll down until I get to it. Yeah, number 9. All right, and I'm going to put 0 up down there, 5 up here. And I already have it in y1, so alpha trace y1. Be very careful not to put an extra parenthesis in there or anything like that. Push enter, and then whatever you get, divide it by 5. Divide it by 5. So my average velocity is negative 0.430 or 431 if you round it. So negative 0.430. I didn't have any units here, so there it is. That's it, guys. All right, this one here, we are going to take a pause so you can see what I'm going to do on delta math in a little bit with it. It says a particle travels along the x-axis such that its velocity is given by blah. So here's my velocity. The position of the particle at x equals 4 is x equals 4 when time is 4. Determine the position, velocity, and acceleration at time t equals 3. Okay, so let's figure out all of those. The first thing I'm going to do, guys, is I'm going to figure out the velocity. So take your calculator out. And again, I'm going to type in those expressions. So second memory 712 to reset everything. And I'm going to go to y equals, and I'm going to type that in. X to the power 1.4. Come down, and I'm going to write plus. So make sure you put a plus there. Sometimes I put a multiply by accident there, guys. 4 sine 2x plus 2, or it's a t, but a t is just like an x in here. And then there it is. So there's my velocity. And I'm going to go to my home screen. Now on Delta Math, they do ask you to round it. So I'm going to go ahead and round it, guys. So my velocity at, what do they want? At 3. So my velocity at 3 equals, all I'm going to do is type in alpha trace y1. And I'm just going to type in 3 and enter. And there it is, 8.613, because I'm rounding it. 8.613. All right, so now I'm going to find my position at 3. My position at 3 is nothing more than the position they gave me. So my position at 4, this, don't get it confused, guys. That's not x equals 4. That right now means my position at time 4. Plus, where whatever number that is, that's my lower limit, 4. And then whatever number I want, that's my upper limit, 3. So there it is. So why does that matter, guys? Because this gives me my position at 4. And then so wherever that stops, this better begin. So there it is. It begins at 4. Let me erase this because it looks kind of nasty here. All right, there we go. And yes, I recognize there's some teachers that like to put a minus there and then go 3 to 4. And yeah, go ahead. It's not hurting anything. When you switch the polarities, you put a minus in the front. And then I write v of t in here. And I'll remember the integral gives you the displacement. So anytime you integrate from 4 to 3 of v of t, that's going to give you my displacement from t equals 4 to t equals 3, guys. All right, so I think I'm good. So let's see, x to 4 was 4 plus, and I'm not even going to, you know what? Let's just go right to the answer. Because I have a calculator. That's the only reason I can do that, guys, here. So I'm going to write x of t at t equals 4. My position was 4. So I wish that number would have been different, but that's fine. And then I'm going to push math number 9, 4 to 3 at alpha trace y1. And then get out of there. Push x here on the side. And negative 3.175. Negative 3.175. Okay, now all we need is the acceleration. The acceleration, guys, we get it from taking the derivative of velocity. So I'm just going to take the derivative, guys. Math 8, if I remember, yep, x, and then I'm going to push alpha trace, or alpha calculate, y1, and at the outside I put 3. Alpha trace. 1.009. And then maybe I would probably show v prime of 3 equals a of 3, guys. 1.009. So we can show our audience that we know calculus and that we know that we took the derivative of velocity, which is acceleration. So there it is, guys. I think that's full credit. And let me show you how it's going to look on your Delta Math real quick. So let's run that really fast. Alright guys, so here's how it's going to look on Delta Math. And we already figured these out, guys. x3, the position at 3, the velocity at 3, and acceleration at 3. So we're just going to plug in those values that we got. So what do we get for position at 3? Position at 3 was negative, this guy's want us to round it, so we round it instead of truncate it. And this one doesn't matter. Negative 3.175. Your velocity at 3, we just plugged in a 3 in the velocity equation, and we had 8.613. If you round it, if you truncate it, it would be 612. And then the acceleration was the derivative, and we got 1.008 truncated, but rounded as 1.009. So there it is, and now we're going to answer questions based off of this. And it's really simple, guys. Let's see, the particle is moving to the, so particle moves either right or left. Well, my velocity is positive, so because my velocity is positive, I am moving to the right. And it says because, and we just choose the one that says velocity positive. Velocity is positive at 3, bam. So there it is, velocity positive at 3, perfect. The next one, the velocity of the particle is, let's see what it says, increasing or decreasing. Okay, well this one depends on the acceleration. The acceleration is positive, so that means my velocity is increasing because the acceleration is positive. So there it is, guys, very straightforward. The speed of the particle. Okay, my velocity is positive, my acceleration is positive, so that means I'm speeding up. So the speed of the particle is increasing because the velocity and acceleration have the same sign. So I'm going to look for that. Velocity and acceleration are the same sign. Perfect. So this one's positive, that one's positive, so they're both, so the particle is increasing in speed. The particle is moving, okay, the origin is 0. Right now I'm to the left of the origin at 3, negative 3.175 is the position. So I'm moving toward the origin because the velocity is positive and my position is negative. So if velocity is positive, you're moving to the right, but I'm to the left of the origin. So hence we're moving towards the origin. So you could say opposite signs. So let's look for that. X of 3 and V of 3 are opposite signs. Bam. So there it is. Let's click submit. Let's hopefully it doesn't get an X there. That would suck. And there it is, guys. We got it. So that's how you do it. It's pretty straightforward, guys. I don't think you guys will have any issues. At least I hope not. If you do, please reach out to me and we can have like a tutoring session over the weekend. All right, guys. Later. Or well, not later because we got to continue, but let's continue. All right, guys. We're back. I hope that you guys thought that was really cool. I thought it was really cool, guys. So in conclusion, if velocity and acceleration have the same sign, particle is speeding up. If velocity and acceleration have opposite signs, particle is slowing down. So speed is decreasing. I hope that made sense, guys. I don't see, like, velocity is negative, you're moving left. Velocity is positive, you're moving right. Find where you are at, like your position. So if it's asking, are you moving towards the origin? Well, if your position is negative and your velocity is positive, yeah, because you're to the left of the origin, but your velocity, you're moving to the right. When it asks, is velocity increasing or decreasing? Well, if the acceleration is positive, velocity is increasing. If the acceleration is negative, velocity is decreasing. It works the same way with graphs, guys. If f prime is positive, f is increasing. If f prime is negative, f is decreasing. See, so it's all pretty much the same, guys. I think you'll be fine. I hope. All right, let's go to the next one. The rate at which the amount of water in a tank is changing can be measured by the differentiable function f, where f of t is measured in gallons per minute and t is measured in minutes. What are the units of 1/437 f of t dt? All right. Without that 1/4, I would have just looked at f of t, and f of t is gallons per minute, and then dt is in minutes. So gallons per minute times minute is just gallons. But looking at that 1/4, this looks a lot like average, guys. The difference between 3 and 7 is 4. So if you remember, average of f was equal to 1 over b minus a integral a to b of f of x dx. Why am I writing it over and over again? Because I'm going to drill it in there, guys. We're going to know this. So let's think about it. So this right here that I'm circling, let's see, gallons per minute times minute, this is gallons. But then you're dividing by time. So because you're dividing by time, that 4, so let's see, gallons divided by time, and that time is in minutes. So that means I have gallons per minute, guys. So I look for that, gallons per minute. I hope that made sense. All right, let's do another one. The rate at which people are entering a line to buy a new piece of technology is measured by the differentiable function f, where f of t is measured in people per minute. Okay, f of t is measured in people per minute, and t is measured in minutes. after the store opened. What are the units of 2 to 7 f of t dt? Okay, perfect. I don't have anything in the front, so I don't have to think about anything. F of t is in people per minute, and dt, t is measured in minutes. So people per minute times minutes is just people. So that's it, guys. We're just doing dimensional analysis. You're just looking at area under that curve. What does it mean? Or just looking at unit analysis, and that's it. All right, example 8. During the time interval 0 to 22, the amount of water in tank in gallons can be modeled by the differentiable function h of t, where t is measured in minutes. I accidentally capitalized that t there. I was going pretty fast, I guess. At time t equals 17, there are 39 gallons of the water in the tank. What is the best interpretation of this statement? Okay, best interpretation, that 39 is right here. That was the initial amount. Initial amount. I recognize, I see that that's h prime. H is, let's see, what is h? H is the amount of water. H is the amount of water where t is measured in minutes. So h of t must be amount per minute, gallons per minute. So this, h of t is gallons per minute. And I'm multiplying by minute. So gallons per minute times minutes is gallons. So this is gallons. And notice I'm adding 39 gallons. So what is this telling me? This is telling me that the fact that it equals 23 is telling me that at t equals 22, is this in hours or minutes? 22 minutes, I have 23 gallons. And I actually did this question real quick, guys. I have a little sample for you for how it's going to look in Delta Math. I think you guys told me that you guys like that. So let me go ahead and show you how it's going to look on Delta Math. It's really simple, guys. So let's go ahead and show that real quick. Here we go, guys. Just like we said a little while ago, that 39 was the initial amount of gallons. H prime of t, that's gallons per minute times minutes, so that's gallons as well. And I noticed that equals 23. So that's obviously how many gallons I have at t equals 22. So the amount of water in the tank is equal to, well, let's see, 23 gallons. So gallons. And that happens at t equals 22. When t equals 22. Now let's submit. There you go. And it really is that simple, guys. So just make sure you know what's up. All right, let's get back at it. All right, we're still going strong. Here we go. The rate at which the amount of water in a tank is changing in liters per hour can be modeled by the function E of t. All right, so before I continue, I'm immediately going to write this is a rate. So this is liters per hour. So it's like a derivative practically. It's a rate, but they call it E of t. All right, where t is measured in hours. The amount of water in the tank at t equals 5 is 44 liters. All right, so this is my initial, or this is how much I have. Select the values of E of t are shown in the table below. Use a linear approximation at t equals 5 to estimate the amount of water in the tank at t equals 4.9. Use proper units. Okay, they're trying to trick us here, guys. This is like finding a tangent line and using that tangent line to approximate. So what we need is a point and a slope. And we have that. We have that. This T544, that is like your point. See, the x value is the time, the y value is the amount that you have. And then that's your time right there. And then the E of t, this is like your slope. Like slope. So we're looking at that value right there. So here we go, guys. So we have everything we need. This is my slope. This is my point. So y minus 44 equals, let's see, my slope, 1 parenthesis x minus 5. So I'm going to distribute the 1. I guess it's just going to be x minus 5 again. And then I'm going to add 44 to it. So 44 negative 5, what's that, 39? 39. And it wants me to approximate how much water is in the tank at 4.9. I'm not going to use E, guys, because E is a rate. So I'm just going to say amount at 4.9. And you can write, instead of Y, you can write amount if you want. It's approximately 4.9 plus 39, which is going to give me 43.9. I think 39, 41, 42, 43, 44. Yeah, 43.9. And I need units. So this is liters. And that's it, guys. Man, tricky guys there. All right, let's go to the next one. The amount of water in the tank in gallons. Okay, so another one. So these guys like tanks. Can be modeled by the function L of t, where t is measured in hours. Selected values of L of t are shown in the table. So this time L of t is just how much water there is in gallons. Approximate the average amount of water in the tank over the interval 0 to 10 using a left Raymond sum with 4 subintervals indicated by the table. 1, 2, 3, 4. Yep, I have 4 of them. All right. Underline the word average amount, guys. Average amount. 1 over 10 minus 0 integral 0 to 10 of L of t dt. There's my average amount right there, guys. So equals 1/10, and then here it is. Here's my LRAM. So I'm doing LRAM, so from 0 to 2, that is 2, the width, and the height is 47. Plus, from 2 to 4, that is 2 again, and the height is 55. Plus, from 4 to 7, 4, 5, 6, 7, that is 3, and the height is 45. Plus, 1, 2, 3, did I already do all of them? This said, oh yeah, 4. 7 to 10 is another 3, and I'm using 36. There it is, 1, 2, 3, 4. It said 4, so I'm good. And actually, you can leave it like that, but Delta Math is not going to want it like that. So let's go ahead and take out the little calculator. Let me get my little calculator out here. And I'm just going to, I'm going to go ahead and add those numbers up, and I'm just going to divide by 2. 2 times 47 plus 2 times 55 plus 3 times 45 plus 3 times 36. If I didn't make any mistakes, enter and then divide that by 10, and we get 44.7. Okay, so let's start thinking about units, guys, because we need units. So this was gallons, and then I multiplied gallons by minutes, so that's gallons minutes divided by minutes, so that's gallons. In case you didn't follow along, guys, let me tell you what I'm talking about. The amount of water in the tank in gallons can be modeled by the function L of t. So L of t, this guy right here, that's gallons. And I'm finding area under the curve with the integral here. So gallons times minutes, that's gallons minutes. But notice that I'm dividing by 10. So 10 is the amount of time. So gallons minutes divided by minutes, and you're just going to have gallons. So this is the average amount of gallons. So it's the average amount of water in the tank. All right, let's go. Oh, it looks like this is our last one here. It looks like a good one. Let's see. During the time interval 0 to 4, the depth of snow on the ground in centimeters can be modeled by the function L of t. So this just tells me how much snow I have in centimeters, where t is measured in days. What is the average rate of change of the depth of snow on the ground from t equals 0 to t equals 4? Okay, there's two ways to do this, guys. You can either think of this as 1 over 4 integral from 0 to 4, average rate of change of the depth of the snow of L prime. If you didn't think of it like that, I didn't think of it like that either. I thought of it like this. I thought of it as L of 4 minus L of 0 divided by 4 minus 0. And they're the same. They're the same. Remember, antiderivative of L prime is L. So L of 4 minus L of 0 divided by 4 minus 0. All right, I'm going to type this into Y1 of my calculator. So let me zoom out a little bit. And Y equals, I'm going to type it in there, 14 sine 0.19 x squared. Close it. And I think I'm ready to go. So I'm going to clear that so I don't have that. Alpha trace Y1 evaluated at 4. Close. Minus alpha trace Y1 evaluated at 0. Close. Enter. Whatever that is, I'm going to divide it by 4. Enter. And there it is, 0.355 if you round it. 0.355. And I need units. So the top is just going to give me centimeters, and the bottom is going to give me days. So this is, or time, which is in days. So centimeters per day. That is the average rate of change of the depth of the snow. And there it is, guys. I hope you guys enjoyed it. Give it a thumbs up. I would appreciate it. And let's take those quizzes and kick some butt. All right. Talk to you guys later. Bye.